Hi everyone, we're just waiting for a couple folks to connect their audio. But while that's happening, I'm going to pass it over to Sean here, who's going to be leading this morning's activity, so he can tell you about the materials you should have in front of you.
Yeah, so my name is Sean. I'll be leading the activity today. I'm an undergrad at Cornell, and I've been volunteering and working at the Science Center for about 2 years now. And today we'll be doing the self-popping bag activity. It'll be a very basic chemical reaction. And I think on our Facebook, the materials were already posted, but I'll go over it again and go over the specific amounts of the stuff you need. So first you'll need a sandwich style sealable bag, so any kind of Ziploc bag really. It's the first thing you need. You need a square piece of toilet paper or paper of any kind. I'm actually going to use a little sheet of paper towel. If you have paper towel, I recommend that you cut it up into at least 1/4 of its size. I found this to be a good size. You need baking soda. And I recommend that you have enough for 2 tablespoons. And then you also need some vinegar. I recommend that you have enough for 2/3 of a cup. And then you also need a bowl to put your reaction in. If you're outside, you don't really need a bowl for this, but I found a bowl to be very convenient since I'm using this big frying pan here. Thanks, Emily. So I hope everyone has their materials by now. So the first thing we'll start off with is the baking soda and the toilet paper. So what you want to do here is you want some baking soda and a measuring tool. So as I said, you want about 2 tablespoons of baking soda. So I want to pour some baking soda into your measuring cup. And it's okay if some spill, it's okay. And what you want to do is put that baking soda onto your toilet paper or whatever kind of paper you have around. So you just want to put it right in the middle. I think you guys can see. Yep, we got some baking soda right there. So you want to do that twice. So I'll give everyone a few moments here to get some baking soda on the piece of paper. It should look just like this, right in the middle. Okay, cool. And then next, I want you to fold all 4 sides of this piece of paper. Make a little pouch for the baking soda. So fold it up in half, then tuck each corner into the top. Make sort of like a little pyramid.
You guys can go ahead and hold up your pouch once it's ready so that Sean knows.
Great. Everyone has their little baggie. Give everyone a few more moments here. Cool. I like it. A lot of baking soda. So next, I want you to take a very small piece of tape. And wrap it around the top of your little baggie. Basically, you want the baggie to be just sealed enough so the baking soda just doesn't pour out. So you can hold the baking soda baggie just like this on the palm of your hand. And I found it useful to use just a little bit of tape. Doesn't really matter what kind of tape you use here. All right. Okay. So if everyone's done with that, next I want you to get your little baggie. Get your little baggie and fill it up with 2/3 of a cup of vinegar, just like that. And should look just like this. So we're gonna leave the baking soda to the side for now, and we'll have this baggie ready. All right, I'll give everyone a few more seconds here. All right, so once you have the vinegar inside your baggie, I want you to zip it closed. Try to get as much air out of it as possible. It doesn't have to be completely vacuumed. I want you to seal it up nice and tight. And then once you seal it, I want you to open just a small opening on one side of the baggie. I would say about half of the Ziploc bag, just enough so that you can drop your little baggie in, which is what the next step is. All right, I hope everyone has a nice enough opening here. All right, cool. Oh, so next you have a little baggie. I want you to drop this baggie inside the bag. And when you do, I want you to close it immediately and put it inside your bowl, just like that. Close it real tight. You should hear some fizzing happening. Just like that. And it popped already.
What are you guys noticing happening with your bags?
There's a gigantic hole in mine and it just popped.
Yours popped already too, Arlo? Did anyone else have their bag pop already?
Yeah, mine just popped. It squirted in a whole bunch of water.
That's really quick. What happened before it exploded?
Some more baking soda.
Is anyone's not exploded yet? And what's happening?
What happened before it exploded? It made a big, like it. Mine didn't explode yet.
So Arlo, you're saying yours blew up. Right, you said yours didn't explode yet. I see Philip, you're holding up your bag. It hasn't exploded, but what's happening to it?
Wait, don't do it.
It's because there's air. It got really fizzy.
Don't help it. It's because there's air coming in.
People are saying it's fizzy, it's filling with air. So does anyone know what's happening here? Where is that air coming
I
from?
think I was involved because it's so big.
Yeah. Let's make another one. That's fine.
So you're actually seeing a chemical reaction in progress. When you combined your baking soda and your vinegar, they changed into something else. They changed into a gas that's filling that bag. What happens when a gas has nowhere else to go in the bag? What did we see?
I'll be scared, Grandma.
It pops.
That's when you get your explosion, right? It can't escape anywhere, so it forces itself out of the bag. Jacob or Jerome, sorry, I need to learn which of you is which. Can you can say something.
Ours haven't exploded, but we're making a new one just in case it won't explode. Because we have a bag that we can reuse.
Oh, okay, that's a great idea. So one of the suggestions that Sean had for this activity is you can play around. You can use some different amounts of baking soda and vinegar and see what happens if you want to do it more times today.
Yeah, if you have a bigger baggie and you're having trouble popping it, maybe start with 3 tablespoons of baking soda with a full cup of vinegar. And you can incrementally increase if you want to. But if you add too much, the reaction is going to be really quick and you won't be able to stop it. So it'll get really messy too.
You can make some predictions about what will happen if you use different amounts. Like if you use more, do you think it will go faster or slower? How much do you think you need to make the bag pop? Lots of things to play with here. Does anyone have any final observations about what's going on before we sign off and let you continue to explore on your own?
It was awesome.
I'm glad you enjoyed it, Finn. I like this one too. It took us a while to get the amounts right.
Yeah. My bag is really strong for some reason. So the actual instructions is 1 tablespoon with 1/3 of a cup, and that didn't pop my bag. So that's part of experimentation.
Yeah, it definitely matters what materials you're using. So that might be why we're getting different results. I see someone's hand up over with Megan. Do you guys want to unmute yourselves and talk?
Yeah.
Say, ours is still.
No, my puppy.
Did it pop?
Oh, it looks really puffy though. How does it feel? Does it feel really pressurized? Don't squeeze it too hard.
Squeeze it.
Yeah.
Keep shaking
It's cool. If you shake it up, you might get your reaction to happen faster, right? You want as much contact between those 2 substances as possible.
There's a hole in the bottom now.
So you're having a very small, very controlled explosion. Maybe you can try some different amounts. Vivian, your hand's up. Want to unmute yourself?
It's cold.
That is a really great observation. Does anyone else, if you feel what has come out of your bag or you feel the bag itself, is it cold?
You need a balloon, Ollie. Is that cool?
So that is because this reaction releases heat when it happens. And so what's left behind is much colder. It's called an exothermic reaction. All right, we have some other hands. Elizabeth, would you like to unmute yourself and share?
So, I'm reusing the bag, and it's and I'm gonna I'm not dumping out the bag. I'm gonna try to use both.
Oh, cool. You're gonna try to reuse your materials. That's a good idea. Also, I want to correct myself, Vivian. So it's not an exothermic reaction, it's endothermic. It takes heat to do. And then what's left behind is really cold. Any other thoughts?
No.
Awesome. All right. Thank you all so much for joining us today. We will leave you to keep experimenting with your chemical reactions. Try modifying the different amounts. And I hope that we'll see you tomorrow at 10:30 as well. We will be doing another activity. I'm pulling up what that is right now. So it looks like tomorrow we're doing an activity about the science of music with one of our friends from Cornell. And so they'll be walking you through making some different musical instruments and exploring with those. Make sure to check out our Facebook page for a materials list on that. All right, thanks so much, everybody. We'll see you tomorrow, and enjoy your chemistry.
Thank you.
Thank you.
Thank you.